Okay, this is the video lesson for geometry, section 3.5, parallel lines and triangles. In this section, we're going to use parallel lines to prove a theorem about triangles, and then we're going to find measures of angles of triangles. So the first theorem that we're going to use parallel lines to prove a theorem about is the triangle sum theorem. And you're going to fill in this blank. So the angles of a triangle always add up to how many degrees? And this is talking about interior angles, so the angles inside the triangle. And so I'm going to show you something first before you answer this. Okay, and then this is just a little video that I took of me moving around a triangle from an applet. So you can see this triangle, no matter where you move it, see the two green angles are always the same and the two orange angles are always the same. And then what do you notice about all three of those angles, right? Or their sum too. Let's see if I can move this. Here we go, so you can fill that out. Right, so no matter where they are, this green one and this green one are going to be the same, this orange and this orange, and we'll use that to prove this theorem in a second, that fact. But you can see in the video, right, no matter where they're moved, right, the angles are changing, but the two greens are the same and the two oranges are the same. Right, and the purple obviously doesn't change because that doesn't move. But then look, well, that was changing too, but it's still there. And then what do we know about the sum? What's the green plus the purple and the orange? No matter where we move it, it's always going to be the same value. And what do we know about the measure of angles of a line? We know that they add up to 180. So you can see here these three orange, green, and purple angles, the three interior angles of a triangle, they're always going to add up, they're always going to form a line, which means they add up to 180 degrees. Okay. All right, so we're going to be using that for the rest of probably geometry. It'll be one that you actually like because it's one a lot of kids remember. And here's the proof. We've kind of already seen the proof just in that little video I showed you. And the proof is going to be using this parallel line. This parallel line is to this side. So if you just create a parallel line through a vertex and then parallel to one of the sides, the vertex that's not on that side, right? And you're given, right, that this is a triangle and this is a parallel line to this one side. You want to prove that these three angles, measure of angle A, measure of angle 2, and measure of angle C add up to 180, right? And so we're given that we have triangle ABC is given. And then we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And that's because of the angle addition postulate, right? Because these angles all add up to create one here. And then also the definition of a straight angle. So with the angle addition theorem, postulate, they all can add up to one value. And then since they all add up to a straight angle, and that straight angle is 180 degrees, that's the definition of a straight angle. And if you're following along in the book, you'll see their proof is a lot more detailed, and they do like a very specific, they substitute and they use linear pair and stuff. But I think this is enough just for you to understand, right, that these three angles all add up to a straight angle, right? And a straight angle is 180 degrees. I think that's enough for a proof for our purposes. Okay, and so then we know that because these two lines are parallel, and then this is a transversal that cuts through those two parallel lines, these two angles are congruent. So measure of angle 1 and, or let's say equal, right? Let's just use numbers. Let's not even bother with congruent. Is going to equal the measure of angle A. Okay, and then we also know that a measure of angle C is going to equal measure of angle 3, and this is by the alternate interior angle theorem. And then, and that's also what we saw in that little video, right? No matter where we move, whatever this changes to, these are going to be the same, and that's because of the alternate interior angles with this parallel line and this parallel line. And so we have those two being equal, and then we can just substitute them right into that original this equation here. Okay, so measure of angle 1 is actually also measure of angle A, since we know that they're the same. We can leave measure of angle 2, and then measure of angle 3 is also measure of angle C. And that's what we're trying to get to, and that is our just by substitution. Okay, and that's, I think, enough for proof. You understand how that works just with the alternate interior angle theorem. So just to always remember these three angles inside a triangle, no matter what, as long as it's a triangle, they're going to add up to 180. And so then let's use them to solve some problems. Okay, this first one I think everyone will like because it's nice and simple. Once you know that the three angles add up to 180, you have two of them, you're left with one. So you take 180 and you subtract your two values that you know, and then what you're left with is the one that you're missing. In this case, it's 25. Okay, and then on these ones, we have 3 different triangles here, right? You have the outside one and you have 2 inside ones. And so if you did the outside one, you'd have to add these 2 together. But if you notice this one, you already have 2 angles there. So you can figure out what z is by taking 180 minus 50 minus 84. I'm getting 46, so that's the measure of angle z. We can write that in. Okay, and then we know that this is a linear pair, right? This is forming a line. So this is going to be, y is going to be 180 minus 46, which is 134. And then now that you have 134 there, you can subtract that from 180 and then also this 13 to get the measure of angle x, which is 33. So we're using the fact that this triangle, right, all 3 add up to 180. These 3 add up to 180, but we also are using this linear pair that we know that these 2 also add up to 180. Okay, and then this last one here is going to be a little bit algebra, right? We see those x's there, and we don't actually see any values given, but we do see this little square symbol, which we know means 90 degrees. So these 3 have to add up to 180, right? And so this one's 90, this one is 8x plus 2, and this other one is 9x plus 3. So if we add all 3 of those together, we're going to get 180. We have 1 variable in 1 equation, so we can solve for x and then plug it back in. So let's subtract this 90 from both sides. And then let's add these together. This is 17x, and then is that a 3? Yeah, and then this is plus 5, and then this equals 90. I guess we didn't really need that 90 step, right? Because we could have combined it with that other 90, but that's okay. Let's subtract 5, so we get 17x equals 85, and then we just have to divide by 17, and 85 divided by 17 is 5. So x is 5. And be careful here, we're not done just because we have x, right? The question is asking what value, find the values of the missing angles. So we're going to have to plug this x back in. So please, I do see this all the time. Students get excited. We've solved for the variable, and then they just leave and move on to the next problem without going back. Wait, what was the question asking? So please remember to look back to the question. If the question says, what is x? Oh, x is 5, you're done. But it doesn't say that. It says, what are the values of the missing angles? So let's fill this back in with our x. So this is going to be 8 times 5 plus 2. So this is 42. And then this is going to be 9 times 5 plus 3, which is 45 plus 3, which is 48. And then just as a double check, let's just add up these 3. Does 42 plus 48 plus 90 equal 180? Yes, it does. So we know that we did it right. So our answers are 42 and 48. Okay, so you'll be using that a lot. So hopefully you'll enjoy your practice with that today. Okay, moving on to exterior angles. So far in a triangle, we're talking about interior angles. These 3 on the inside are interior angles. But there's a specific type of angle that is formed on the outside of a triangle when you extend one of the sides of the triangle and create a line on the outside. The angle that's formed between the other side and that line is called the exterior angle. And then there's another type of angle that's related to them called related to the exterior angle called the remote interior angles of the exterior angle. And this question is asking, what do you think are the remote interior angles? So if you think about the word remote, like remote control, right? You can sit at your couch and change the channel remotely by not touching the TV. In this case, remote would be not touching, and then there are interior angles. So out of these 3 interior angles, which ones are not touching this exterior angle? Well, 3 is touching it, so it's not 3, but these 2 are not. So 1 and 2 are actually called the remote interior angles for this exterior angle. And there is a special relationship between the remote interior angles and the exterior angles, which we're going to find in these examples, and we're going to look for a pattern here. So if we're trying to find, this is find the exterior angle in each problem. So in this case, we've extended this line here. So this is the exterior angle. In this example, it should have been a straighter line. Sorry about that. This is the exterior angle we're looking for. And then this one, we extended this, and we're looking for this one. So to find these, we know that we can find this angle, right? Because these 2 added together and then subtracted from 180 equals this, right? Because these 3 have to add up to 180. So this is 130. 180 minus 130 is 50. right? 180 minus 30 minus 100 equals 50. And then, because this forms a straight line, this becomes 180 minus 50, which is 130. So that's how we can find these, right? So we add these up. This is 150. Oops, 150. And then subtract that from 180 to get 30. That's what this one is. And then we do 180 minus 30 to get 150. So this one's 150. And then here we add these two, we get 90. Subtract that from 180, and this is also 90. Subtract that from 180, and this is also 90. So that's how we find that. And so this question here is looking, find the exterior angle of any problem. We did that. Do you notice a pattern? So let's see this pattern. This is 130 here. This one is 150, and this one is 90. And maybe you will notice that, look, these two remote interior angles are 130. They add up to 130. That's the angle here. Like these two were 150 and this one's 150. These two are 90 and this one is 90. So that pattern does hold for all exterior angles. Right, and that's because these two add up to, when we add these up and subtract from 180, we get this number, and then we have to subtract this number from 180. And so we go back to that number. Right, so that's why that works. And here is the theorem for that on this page. The measures of each, and this is called the triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of its remote interior angles. Okay, and so that helps us to solve these triangles a little bit easier than what we were doing before, right? So if we're going to do these two, now that we know that, instead of finding two, it's actually easier to find one first, right? Because we know it's just the two remote interior angles. 70 plus 38 is going to be this guy. This is 108, right? And then we can just subtract that from 180 here, which we were going to do that anyway to get that one. And then we'd have to subtract it from 180 again. So it's kind of saving a step. And so since this one is 108, we're going to subtract 108 from 180, and we get 72 for the measure of angle 2. Right, this one's for measure of angle 1. Okay, and then on this one, we were solving one like this before already on the first page, just with the interior angles being 180, but we can do it a little bit faster with our triangle exterior angle theorem. Right, this y is an exterior angle, and these are the two remote interior angles of that. So we can just add those together. 85 plus 28 is 113. So this one's 113. And then we can subtract that from 180 to get this one and get 67. And then we know that these two have to add up to 67. So we can subtract 17 from 67 and get 50 there. So you could also just use the fact that the interior angles add up to 180. It'll just take a little bit longer. So just remember that the triangle exterior angle theorem says that the measure of each exterior angle of a triangle equals the sum of its remote interior angles. Okay, and so this last one, I have a red star there for you to try on your own, but I'm actually going to do it with you. If you want to try it on your own, you can press pause, but I'm going to walk you through it. So this says the ratio of the angle measures of acute angles in a right triangle is 2 to 3. Find the measures of the acute angles. Okay, so we have a right triangle, which means one of the angles is 90. And so the other two are the acute angles, and their ratio is 2 to 3. So this is the ratio, which means in actuality, it's some value when you divide out, well, they're both two numbers that have the same similar factor, that when they cancel out, the factor cancels out, the remaining resulting ratio is 2 to 3. So the actual angle we will call 2x, and the other one we will call 3x. So that's how you do problems when they give you the ratio. You have to add in this factor that would cancel. Okay, so then once we have that set up, we know that the interior angles of a triangle add up to 180, so we can set up an algebra equation. 2x plus 3x plus 90 is going to equal 180. We can combine these to be 5x, and then we can subtract 90 from both sides. And so 5x equals 90, then we just have to divide. 90 by 5, and we get 18. So x equals 18. That's not the answer, remember, just because we have our x. Let's look back to the problem and see what it's asking. Find the measures of the acute angles. These are my two acute angles. We know that x is 18, so we can plug in 18 for x. 2 times 18 is 36, and then 3 times 18 is 54. And let's just do a double check on that. Let's make sure 90 plus 54 plus 36 equals 180. And it does. So we're good. So the answer is 36 and 54. Okay, time for practice. Enjoy.